Hello students, now we'll talk about the calculation portion. Calculation portion of stoichiometry. The mole concept we have previously discussed about these basic calculations and now with basic concept, and now calculation portion we just about the except the mole concept we will study the most important things which are remain in this topic. That is, first is significant figures and round of figures. Second is round of figures, and third one is, oh, just mark others put down, and the third one is we will study significant figures, round of figures, scientific notation. And the fourth one is empirical formula. So how can we study about these given topics in this chapter? So we will discuss these things: significant figures, round of figures, scientific notation, empirical formula, one by one. And if we come to the next point, just significant figure. So significant figure, we will study significant figure. Significant figure is the mathematically true expression which determines the certainty of any number. For example, there are 4 rules. We just oftenly remember this thing, that if any number is written as 0.0037 like this, and how many significant figure is, first thing remember in your mind, if any number started from 0, then it is not, then these digits are not considered in any numbers, and after the decimal is also 0, not considered. If the numbers start from 2, then the whole digits will be considered. So first thing is this: if any number start from 0, then there is only 2 significant figures. There is only 2 significant figure if any number is starting from 0, and after the decimal there is also a 0, not considered as a significant digit. 3, 7, these are the significant figures. So how many significant figures? Is just 2. What is the value of significant figure in this number? Is 2. And if I write about any number like this, 2.34000, so this is considered as significant figure. This number is considered as significant figure. 1, 2, 3, 4, 5. After the decimal, 0 will be counted. So 1, 2, 3, 4, 5, 6. So there is 6 significant figure. And if any number started from, I have told you, 2.0045, then there is 1, 2, 3, 4, 5 significant figures. So these rule you should know about it. And if a number is written as just like this word 2.000, how many 0 you will put it on after the decimal, and these are considered significant figures. So 1, 2, 3, 4 significant figure are on here. So this is all about the main concept of significant figure you should know. So round of figures, we'll talk about the second point. Round of figures, it means for 2.3056, if I will say round of this number up to the 2 decimal places. So 2 decimal places, if I consider is this, and after this any number we just see it, if it is greater than 4, then we will add one number before if the number is greater than 4, then we can add one number on just one place before of it. So after the 2 decimal is given, if I given, so its round of figure will be like this, 0.31. it will be edited. So 2.31 is the main round of figures. And if I'll say just round off up to the 1 decimal places, so its number will be 2.3, because 3 is small number. If number is less than 4 or great, so it will be written as it is, And if a number will be greater than 4, 5, 5 and greater than 5, so it will be written as adding one extra digit before its term. For example, if this number will be like written this 3.36, so if will we say, then round off this figure up to 2 decimal places, so 2.30 will be the okay, because the next number is just less than 3. Number is less than 3. So this is all about the round off figure up to how many decimal places you can calculate, and you can round off any number like this method. Next is the point is scientific notation. So scientific notation is just like that. If a number is written as n into 10 to the power n term, means if a number is written as 3465.6 into 10 to the power 12, so in scientific notation, the notation says that the number will be written after the one digit. So 3.465 into 10 to the power, just count the number before it, 1 2 3 4, so 15 we can write it. So if we increase the 10 to the power, more power we just put after the one digit. And if a number will be written like this, 0.00056 into 10 to the power minus 10, so this number can, or we can say 10 to the power okay minus 10. So how can this number will be written? This number, how can this number be written? This number will be written like this, 5.6 into 10 to the power how many term? 1 2 3 4. So adding 4 minus term, so minus 10 minus 4 is just minus 14. So minus 14 will be raised its power and written like this. So in this form you can calculate the scientific notation. As scientific notation, you can write the any number in the form of scientific notation. So many constant you have seen in physics and chemistry, just like any gravitational constant. If I talk about the 6.67, like this form is written. Avogadro number is always written like this form into 10 to the power 23, because these follow the scientific notation concept. So after the one digit we just place decimal, and remaining 1000, 10, 100, the numbers will be raised to the 10th powers. So in this way we can easily calculate significant figure, round of figures, and scientific notation. What are the empirical formula? How can we calculate the empirical formula? Empirical formula is just tell about the simplest formula, and molecular formula tell about the exact number of atoms of elements in that molecule. So this is the simplest formula, it's known as empirical formula. And how can we calculate the empirical formula of any number? So you can learn and understand this thing very well on here. So we'll break down this concept in a very easy manner, so it will definitely help for your exam. By this method you can easily calculate any question regarding the empirical formula. Let's suppose if any question is just given like this, yeah, in this any question given like this, any compound in which chlorine has 70, just like or we can say starting, sorry, in which hydrogen has 4.07 percentage abundant, and percentage of, and chlorine has percentage abundance, sorry, carbon has percentage abundant like this, oh what carbon has percentage abundant like 24.05 something percent, and chlorine has percentage abundant like this, 35.5 something. So sorry, 71.65, just like that. Percentage abundance are given of the element hydrogen, carbon, chlorine you have in such a manner. So calculate the empirical formula. How will you calculate the empirical formula of the given compound? The situation is given like this, so how can you calculate? The simplest method to calculate such type of question is this. First we will put the value of, we'll make the table elements. It is the easiest and systematic manner you can use. Elements and the number we can use is relative number, and here just simplest number. So how can you calculate the relative number? Elements is given like the percent elements is just given hydrogen, carbon and chlorine. So hydrogen percentage is given 4.07. So if we divide the mass of, we just divide the atomic mass in each percent abundance to get the relative number, we will get near about, we can write it's 4, and carbon is just given, we have given a carbon has 24.0, so 24.05 divided by 12, and it may be written as nearby 2, and chlorine is 71.65 divided by 35.5, and it may be written by 2 also. So if we divide the simplest number, we choose the smallest number and divide by each. The smallest number is 2, in this here is 2, both are same, so we can divide by 2 each number, 2 by 2 and 2 by 2. We will get 2, we will get 1, we will get 1. So whatever the numbers we just get in the end of, by calculation of it, they can say C HCl, we just write it on here, and how much C and how much H2 and how much Cl is 1. So we just have an empirical formula like this. This will be the answer. So this is the empirical formula we'll get like this. In this way you can easily calculate the empirical formula of any number in this form, whatever the percentage when is given divided by its own mass of an atom. So after dividing by its atomic mass, you will get the relative numbers, and choose the smallest number and write the simplest numbers of elements. So here is the CH2Cl is the empirical formula we will get in this question. In this way you can easily calculate the relative questions of your academics. Thank you.